Okay, I'm going to do experiment 2 of this online circular force lab because it's the one where we're changing the mass, and that might be the hardest to think about with the graph. So I'm going to start here, and I'm just going to keep, I guess, 10 washers on it every time. And so if I take 10 washers, and each one's 10 grams, I'm going to take 10 times 10. I'm going to divide by 1,000 to put it into kilograms. I'm going to take it times 9.81 to get it into newtons. So my constant force over here, that I'm never going to change that for this experiment, is going to be 0.981. The radius is set at 200 centimeters or 2 meters. I'm not going to change that either, so I'm going to leave it at 2. Okay, so what I'm going to do is I'm going to change the mass 5 times. So the first mass I'm going to do is 0.025 kilograms, which is right here. Okay, and we'll let it run and we'll see what the velocity is. So we'll let it go here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, didn't stop it really great, but that's all right. So that was 10 times. So we're going to take 10 revolutions times 2 pi r, and then we're going to divide it by the time for me here. Let's see, let's do revolutions, and this will be time. Let's see here. Give me my revolutions. There will be my time in seconds. And let's see, the radius is over here at 2. It's always constant. So this is going to be my velocity. Actually, my velocity would go right in this column. So what I can do is I could put in 10, and I can put in the time. I'm going to have this do it for me every time. Time would be 14.4 seconds. So how do I get my velocity? Well, my velocity is going to, I'm going to do a formula. It's going to be equals this cell times 2 times pi. I'm just going to do 3.14, make it easy, times this radius right over here. But I'm going to want to refer to that radius every single time. So I'm going to put some dollar signs there in front of the B, in front of the 5. So when I drag it down, it's still always getting that radius. Okay, and then I need to divide it by this time right here. And I'm going to have a different time there every time, so that'll work. Okay, so there's my velocity, and I will kind of shrink it down a little bit there. And I'm going to take this velocity 1, 2, 3, 4, 5. I'm going to take it down 5 times. So now all I have to do is put the revolutions and the time in here, and we'll be good. Okay. So I'm going to change the mass. Where's the mass? Oh yeah, right. Oh, okay. Reset. And then I'm going to go 79. So I'm going to put a 0.079 mass in there, and we'll go ahead and start it. 1, oh boy, 2, choose a bigger force, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, this is going to be bad because it's going to get slower and slower. All right, so 10, well, I guess I'm doing the 10 revolutions every time. I didn't need to, well, maybe I won't do 10 revolutions next time. 25.4 seconds, 25.4 seconds. So there's my new velocity. Okay, reset. 141, so that's 0.141 kilograms. And we're going to start it. I'm not going to go as many times this time. 1, 2, 3, 4. I'm just going to do 4. 13.5 seconds. So 13.5 seconds, but I'm going to do only 4 revolutions that time to get my velocity. Let's see, G6, yeah, okay, times, all right, that 2 pi r That's good. Okay. All right, reset. 202.202 kilograms. And we're going to start. 1, 2, 3. So 12.1 seconds. 12.1 seconds, and I only did 3 revolutions that time. Okay. And then reset and 250.250. Okay. And start. 1, 2, 3, 4. See, if I would have put a bigger force on the beginning as my constant, it would have been better. 5, because then it could have been quicker. All right, and 6. That's good enough. Okay, so 6 revolutions, and what was the time? 27.1. 27.1. So there's my velocity. Okay, so now I got to make a graph. So I have velocity here, and I'm going to graph velocity squared on my y-axis. So I'm going to go right here real quick and equals, click that cell, do a caret 2, that'll square it. Okay, and then I can go ahead and drag that down. Okay, and then I'm going to actually on my x-axis, I'm going to graph 1 over mass. If you remember, it was v squared would equal fr times 1 over mass. So that's y equals mx. So I want to actually have 1 over mass as my x. So I'm going to do equals 1 divided by the mass, hit return, and I'm going to drag that down. Okay. Now, so the slope that we would predict, remember the force was 0.981 and the radius was 2 meters. So our predicted slope is actually FR. If you look at your equation, we have V squared, which is the Y, equals FR, which would be your slope, times the X, which is 1 over M. Then your predicted slope should be force times radius. So I'm going to do equals this force times this radius. And that right there should be the slope of the graph that I make when I graph 1 over mass versus V squared. That's what should be happening, I believe. Oh, wait a minute. Yeah, that's all right. Okay, so I'm going to insert a chart. And I'm going to actually, I don't want column chart. I want a scatter chart. Okay, here it comes. And it looks pretty good. So mine kind of worked out great the first time. It looks like a pretty straight line. If you want to look over here on the setup, you want to make sure things are right. So sometimes things might kind of mess up a little bit. So it should be scatter chart. It should be the data range should be, the 2 columns. So like mine's D3 all the way down to E8. So in this data range here, it should say like D3 to E8. That's including my header right there. Okay. If it doesn't say that, click on this little thing right here and go ahead and make sure that you can select the range or something. So if it just kind of came out wrong, just check that. And then you'll be able to, in here in the drop down, you'll probably be able to choose the correct x-axis, and the series is your y-axis. Okay. And then down here, it should be like use column D as labels. Okay. Let's see if I unclick that, see it's going to be messed up. So use column D as labels. And it should be something like that on the setup part. Okay, and then you need to go to the customize part, and then like you could change the chart style if you want to make it, change the background color to something, I don't know, pretty or something. It's not very pretty. All right, then chart and axis titles. Chart title, I'm just going to do experiment 2. I can do the horizontal axis title is actually 1 over M. And the vertical axis title is V velocity squared. Okay. And so that's all not that important stuff. The important stuff is go under series And we want to come down here and put a trend line through it, and it looks pretty linear. If you want to see how linear it is, you can actually click on the R squared value. I don't really need that, but that look, R squared equals 1. So this is an extremely linear relationship between V squared and 1 over mass, which of course it should be. You can unclick that. I don't really need that on there. It's just extra stuff. So under label where it says custom, you need to use the equation. Now remember, we should have y equals mx, and the equation should be y equals, we're looking at 1.96 times x. So here we go. Very exciting. Ooh, 1.89. Not bad, not bad. Okay, so we predicted a slope of 1.96. We got like about 1.89. Actually, there's a y-intercept right there. So we didn't like predict a y-intercept. So a little error involved in when we clicked it on the thing. So that's what you'd need for like experiment 2. You can shrink this down. Eventually, you're going to kind of print off this little section here, print off the graph, print off your predicted slope, or at least print off the graph, and in your inquiry, write how you predicted that slope before we ever even did it. So that's how to do experiment 2. The other experiments are, I think probably maybe even a little easier because you don't have to do the 1 over mass for your x. You can just graph force as your x-axis. You can also graph radius as your x-axis.